Hi, this is Achinta Medi, and this is the second video of Chemical Kinetics chapter. In this video, I'll discuss about kinetics of first order reaction. So first of all, we have to consider a reactant, that is A, which is converting to product P. Okay, so when at the initial state, when time is 0, then amount of reactant will be A and amount of product will be 0. So when time is t, a small amount of, when time is t, then a amount of reactant will convert it to product, that is x. So a minus x remains as a reactant. So if we write the rate, we can write dx by dt. So dx by dt indicates or defines the rate of reaction of first order reaction. So dx by dt will be proportional to rate. That means rate is proportional to concentration of reactant, and there will be a power here, and as it is the first order reaction, so there will be a 1 here. Okay, next we can write what dx by dt is equal to, we will bring a constant, rate constant, that is k1, as it is the first order reaction, so we will write k1 and it will be concentration of reactant. So we can write dx by dt is equal to k1. Instead of this a, we will put a minus x. So we can write okay, so we can write dx, we will bring this a minus x here, a minus x, and dt will come here, k1 dt. Okay, so when we integrate this equation, we will get what, dx a minus x k1 dt. So it will give you ln a minus x is equal to k1 t plus c. So c is the integration constant. So when time is 0, that means this part is 0. Okay, so c will be equal to this part, but when time is 0, that means the initial state, you can see that when time is 0, product, there will be nothing like product here. Okay, so it will be 0, so it will only, we can write c is equal to ln 1 by a. So when we put this value, c value, here in this equation, we will get ln a minus x is equal to k1 t plus ln 1 by a. This will be equal to, we can write this part, we will bring that ln 1 by a over there, a minus x ln 1 by a is equal to k1 t. So it will be ln 1 by x a is equal to k1 t. We can write ln a will be here, a minus x is equal to k1 t. Okay, so we can write that constant is equal to 1 by t ln a by a minus x. Okay, so if you want to write this equation in terms of log, as you can see it is ln, so if you want to write as log, so you have to multiply 2.303 here, and t will be here, and this will be log a by a minus x. So this is the final equation. This is the final equation for the first order kinetics, first order reaction. This will be the final reaction equation. Next, if you want to evaluate the half-life, then what will be that? Half-life means when t is equal to t half. Okay, this is a minus x, a by a minus x. So when t time is t half, then at that moment we can say that this converted reactant to product form, this amount will be a by 2. Okay, half of the reactant will be converted to product, so this part is equal to a by 2. And we can also say that as it is a by 2, so it will be a by 2. Okay, this a by a minus x is equal to a by 2. So we can put this a by 2 instead of a minus x. So we can write k1 is equal to 2.303 divided by t log a by 2. Or you can write also ln equation also. So if you write ln, it will be easier to understand. Ln, it will be a will be cut off, and there will be ln 2. So ln 2, we can write ln 2 means into 0.6930. Okay, so we can write this is t half, so t half will be equal to 0.6930 divided by k1. So this is the equation for t half-life of first order reaction. T half is equal to 0.6930 by k1. Next, if we discuss about quarter life of first order reaction, then you can see that the A reactant is converting to product P. So when time is 0, A and there will be product will be 0, and when time is t quarter, that means 1 by 4th, when t is t 1 by 4th, then you can say that this part a minus x, the remaining part of the reactant, is a by 4. So you can say that this x part will be 3a by 4. Okay, so if we put this a minus x value in the equation of first order reaction, k1, as we know that k1 t ln a by a minus x. So this is the equation for first order reaction. So we will write t 1 by 4th, t 1 by 4th will be here, and k1 will be here. Okay, so k1 will be here, ln a by this a minus x, we will write instead of a minus x, we will write a by 4. So a will be cut off, and it will be 1 by k1 ln, and 4 will be here. Okay, so it will be 4. So we can write t 1 by 4 is equal to ln 4 by k1. So ln 4 will be equal to 1.38 by k1. Okay, so this is the final equation for quartile life of first order reaction. If you want to discuss about the unit of first order reaction, as I have already discussed in the earlier video, as I have told that to evaluate the unit, to know about the unit of any kind of order of reaction, the general equation is liter n minus 1 mole 1 minus n second inverse. So in case of first order reaction, n will be equal to 1, so L 1 minus 1 mole 1 minus 1 second inverse. So it will be, this will be 0, this will be this will be 1, this will be 1, as it is mole 0, liter 0, to the power 0, to the power 0, and second will be inverse, so it will be only second inverse. So unit of first order reaction is second inverse. Now for better understanding, let's solve a problem. So we can see the problem here. If a first order reaction complete 50% in 7 minutes, then how long will it take to complete 87.5%? So in 7 minutes 50% is completed. So first of all we have to write what is given here. So 50%, okay, so 50% k1 is equal to 2.303. this is the general equation, t, and it will be log, as I am writing 2.303, so it will be log. If I will not write this 2.303, then it will be ln. Okay, so log 2. Okay, so in the entire reaction, rate constant will be same, whatever the time, but the rate constant is same in all over the reaction. So in this reaction, whether it is 50% or 87.5%, the rate constant will be same. So we can put this k1 value. Okay, so we can write this t is equal to 7 minutes. Okay, so we can obviously calculate log 2 value, we know that, and this is given 2.303 and time is also given, so we can calculate this rate constant, and this rate constant we can put this value of rate constant in case of 87.5% completion. Okay, so in case of 87.5%, it will be, we are going to evaluate the time, so we will write t here and k will be here. Okay, so this k rate constant is same all over the reaction. So in case of 87.5% also, the k is the same. Okay, so it will be log 100. That means the, as we know that t is equal to 2.303 by k log a by a minus x. So here we consider a is 100 and a minus x when 87.5% is completed. So a minus x, 100 minus 87.5, so it will be 12.5. so we will write log a by a minus x, so a will be 100, a minus x will be 12.5. so we can write t is equal to 2.303 divided by this value, 2.303 divided by 7 log 2. Okay, so this value is log, this will be 8, so it will be 8. so log 8 we can write, log 8 means 2 to the power 3, 2 cube, that means 2 cube. Log 8 means this one, so 3 will come here and log 2 will be here, so it will be so we can write this will be cut off 2.303, 2.303, so 7 will be here, 7, and log 2 is here, log 2. Okay, so we can write, instead of log 8 we can write 3 into log 2, 3 into log 2. so log 2 will be cut off, and there will be only 7 into 3, so it will be 21 minute. Next, when we plot log a minus x versus time, so what will be the graphical representation? So first of all we have to know the general equation for first order reaction, then only we can evaluate the graph. Okay, the first equation is, general equation is t is equal to, as it is their question asked that it is in terms of log, so we have to write 2.303 divided by k1 log a by a minus x. so this is the general equation. so we can write k1t divided by 2.303 is equal to log a minus log a minus x. so this is a rule of logarithm, as it is a by a minus x, so we can write like this. It is divided, so we can write in terms of minus, log a minus x. so we can write log a minus x is equal to minus k1 by 2.303 t plus log a. Okay, so we are plotting graph log a versus time. Okay, versus time, so it is y is equal to, this is mx plus c, so it is a equation for straight line. Okay, y is equal to mx plus c defines that, indicates the graph of straight line. so this is a graph of straight line, so this will be y, as we are plotting versus time, so it will be x, and c it will be intercept, c will be intercept, and m will be slope. so the graph will be like, so we can write slope is equal to k1 2.303 and intercept is log a. so we can plot here y will be here, so it will be log a minus x, and t is x here, so t will be here, and as it is negative, so graph will be like this. Okay, and this will be the intercept. The intercept is log a, and slope will be negative, so slope will be minus k1 by 2.303. so this will be the graph. When we will plot graph concentration Ct versus time t, so we have to write a there will be a product. So when time is 0, it will be C naught, it will be 0. When time is t, it will be Ct, and it will be C naught minus Ct. So we are going to plot Ct versus time. So from the general equation, what is the general equation? 1 by t ln a by a minus x. So here we can write t, we can bring this t here, so it will be k1t ln. So here a is c naught. Okay, the initial amount of reactant, so it will be c naught. Okay, and a minus x, that means the remaining part of reactant, that means the Ct, so it will be Ct. Okay, so if you want to remove this ln, so we have to write e to the power k1t is equal to c naught by Ct. Okay, next we have to invert this part, that means Ct by c naught. Ct will come here and c naught will be here. So if you invert this part, then you have to invert this part also, so it will be e to the power minus k1t. There is a positive sign here, but as you invert this, so it will be k e to the power minus k1t. Then we can write Ct is equal to c naught will be here, we can bring this c naught here, so c naught e to the power minus k1t. So as you know that it is exponential, and there will be a negative sign is here, so you can say that this will be a exponential curve, and as it is negative, so it will be the curve will exponentially decreases. Okay, so graph will be like this. So here it will be Ct, and here it will be time x, so it will be like this. So graph will be exponential, the graph will exponentially decreases. So in this problem, nitrous oxide N2O decomposes in N2 and O2. Okay, and the products being all gaseous. If the reaction is first order, develop expression for the rate constant as a function of time, initial pressure and total pressure. So we are going to evaluate a equation in terms of function of time, initial pressure and total pressure. So first of all, we have to know the equation, reaction, how it decomposes. Okay, so it is gas, then it will be decomposed to N2 and half of O2. It is also gas, Okay, so let the initial pressure. Initial pressure of N2O gas is P initial. Okay, P initial. Then if X is the decrease in pressure after time t, then we can write P N2O. That means pressure of N2O. Pressure of N2O will be after time t. After time t, pressure of N2O will be Pi minus X. Okay, you have to notice that there will be a 1, there will be a 1, and here it is half. Okay, so as X mole of N2O is decomposes to X mole of N2 and X by 2 mole of O2. Okay, so we can write P N2 pressure, so it will be X, and PO2 will be X by 2. Okay, next, according to Dalton's law, of partial pressure, the total pressure of the system at time t is given by P is equal to, we have to sum, according to Dalton's law, we have to sum all these three partial pressure. That means P N2O plus PO2 plus PN2. Okay, so for PN2O it will be Pi minus X, and for PN2 it will be X, plus for PO2 it will be X by 2. So it will be cut off, and here it will be only Pi plus X by 2. Okay, so we can write P is equal to Pi plus X by 2. Okay, so it will be X by 2 is equal to P minus Pi. Okay, so we can write X is equal to 2 into P minus Pi. Okay, so from the general equation of first order reaction, what we know that K1 is equal to 1 by T ln A by A minus X. Okay, as we know that, so we can put here what, 1 by T ln, or you can, we are going to evaluate the rate in terms of time. Okay, so it will be T ln, and A it will be the, that means initial pressure is what, Pi, and it will be A minus X. So Pi minus X means this part. Okay, 2 P minus Pi. Okay, so it will be ln Pi minus twice P minus plus 2 Pi. It will be T ln Pi thrice Pi minus 2P. So it is solved that K1 is equal to 1 by T ln Pi by thrice Pi minus twice P. This is the final equation. So in this question, 5 ml of ethyl acetate was added to a flask containing 100 ml, 5 ml ethyl acetate and 100 ml of 0.1 molar HCl placed in a thermostat maintained at 30 degrees Celsius. 5 ml of the reaction mixture was withdrawn at different intervals of time, and after chilling titrated against a standard alkali, the following data were obtained. So these are the time and these are the alkali used, ml. These are ml. Okay, so from this data we are going to show that the hydrolysis of ethyl acetate is a first order reaction. Okay, so in this question we have to know a general equation, which is K1 is equal to 1 by T ln V infinity minus V naught by V infinity minus V d. So if the data given in the question, if the data confirms this equation, then we can say that the hydrolysis of ethyl acetate will be a first order reaction. So first of all, we have to show that this data confirms this equation. Okay, so in this case it is the rate constant, this is time t, and V infinity, that means when time is infinity, at that moment the volume of alkali used, that means this one 21.05, and V naught is the initial time at which alkali volume of alkali is used, that means this one, and 9.62, and this is also same, and Vt is any time, that means it will be 75 minutes also, it may be 119 also, it will be 183 also. So at that time Vt will be, maybe Vt will be 12.010, 13.10 or 14.75. okay, so first of all we have to calculate V infinity minus V naught is equal to 21.05 minus 9.62 is equal to 11.43. So the values of K1 at different times are obtained as below. Okay, so here it is time, it is V infinity minus Vt, and it is the general equation, that means K1 is equal to 1 by T ln V infinity minus V naught divided by V infinity minus Vt. Okay, 75 minutes, when it is 75 minutes, and it will be the volume, so it will be V infinity, that means 21.05. okay, so So 21.05 minus Vt, that means 75 minute, and it will be 12.10, so it will be 8.95. so we have to calculate like this. 75 t means 75, so we put this 75 here. ln v infinity minus v naught, as we have calculated, so it will be 11.43 divided by v infinity minus vt, that means this part 8.95, so it will be 0.003259 minute inverse. So when next we will calculate when time is 119 minute, it is minute and it is also minute, so it will be 21.05 minus, so it will be the volume is 13.10, so 13.10 is equal to 7.95. so time is 119 ln, it will be same for every time, and here it will be 7.95, this one, so it will be also 0.003264 minute inverse. Next we will calculate 183 minute, so it will be 21.05 minus, so for 183 the time is volume is this one 14.75, it will give 6.30. okay, so it will be time is 183 ln 11.43, and it is 6.30, it is 6.30, and it will give 0.003254 minute inverse. okay, so as you can see that this value and this value are almost same to each other, so we can say that these all are rate constant. So from this value of rate constant we can say that the hydrolysis of ethyl acetate is a first order reaction, as the data confirms that it is a first order reaction. Let's solve another problem. So in this problem is saying that the optical rotation of sucrose in 0.5 molar HCl at 35 degrees Celsius at various intervals are given below. Show that the reaction is first order. So these are the time and these are the rotation. So in this question also there is a general equation, so this data should confirm the equation, then only we can say that the inversion of sucrose will be a first order reaction. okay, so the general equation is what? K1 is equal to 1 by T ln R naught minus R infinity divided by R T minus R infinity. okay, so to memorize this equation easily, you have to think about the earlier equation, and what was that in the previous question? It was K1 is equal to 1 by T ln V infinity minus V naught and V infinity minus Vt. okay, so difference is that it is just inverted. V naught is here, V infinity is here. you can see that r naught is here and r infinity is here, and this is also inverted. T will be here, infinity will be here. So these two equations are almost similar, but this position of infinity and naught and t are opposite to each other. Okay, so you can memorize this equation like this. Okay, so now we are going to show that r naught minus r infinity is equal to plus 32.4 minus this is, that means r naught is this one, so I am writing 32.4 minus, next this infinity, r infinity is this one. Okay, so we can write as is 43.5. okay, next, now the value of k1 at different times are calculated as below. Okay, so first of all is time, next this is r t minus r naught, infinity, and here it will be k1 is equal to the general equation I am writing r naught minus r infinity by r t minus r infinity. Okay, so first of all time is 10 minute, so it will be 10 minute to t, that means when 10 minutes it will be 28.8 minus r infinity means this one minus 11.1, so it will be 39.9, so it will be t is 10. Okay, ln r naught minus r infinity, as we have already calculated, this is 43.5, and rt minus r infinity, that means this one 39.9 is equal to 0.008625 minute inverse. Okay, so when time is 20 minute, that means this is the rotation, 25.5 minus 11.1 is equal to 36.6. so time is 20 ln, this will be the same 43.5 and it will be 36.6, so it will be also 0.008625 minute inverse. Okay, next we will calculate for 30 minute. So for 30 minute also it is 22.4 minus 11.1 is equal to 33.5. so for time it will be 30 ln, and it will be same 43.5 divided by this one 33.5 is equal to 0.008694 minute inverse. Next we will calculate for 40 minute. 40 minute is equal to this one 19.6 minus 11.1 is equal to 30.7. 40 ln, it will be same 43.5, and we will write this 30.7. okay, so it will give you 0.008717 minute. So as you can see that this 4 value of k1 rate constant, so these 4 value are almost same to each other. So it is showed that the inversion of sucrose is a first order reaction. Okay, let's discuss about radioactive decay as a first order phenomenon. So before knowing that, we have to know about radioactive decay. What is radioactive decay? So there are some substances in earth, present in earth, and from those substances, when some energy or light strike those substances, then very minute particles separate from those parent atom or parent substance, and those minute particles are like alpha, beta, gamma, and those substances from which this alpha, beta, gamma particle separated, those substances are called radioactive substances, and from which as particles separated, so those particles continuously separated, and that's why some radioactive decay occurs. So now we are discussing radioactive decay as first order phenomenon. So when radioactive substance is separated from its parent and its activity is measured time to time, then the rate of decay follows the law as this equation, minus di by dt is equal to lambda I. So here I is activity, t is the time, and lambda is a constant which is called radioactive disintegration constant. Lambda is radioactive disintegration constant. So when we integrate this equation, what we will get, di by dt is equal to lambda, first of all we have to bring this I to here, it will be I, and dt will come here, so dt will be here. Okay, so we can write minus ln I, and this integration will from I naught to I, so it will be I naught and it will be I, and lambda t. So we can write ln I minus, and it will be plus ln I naught is equal to lambda t. Okay, so we can write ln I naught by I is equal to lambda t, or we can write ln I by I naught is equal to, it is I naught by I is equal to e to the power lambda t. Okay, so when we invert this, I will be here and I naught will be here, so it will be I and it will be I naught. So as we are inverting this, so we should invert this part also, so it will be like this. That means this part is inverted like this. So we can write e1 by e to the power lambda t as e to the power minus lambda t. Okay, so we can write like that. So it will be I is equal to I naught e to the power minus lambda t, where I naught is the activity when time is 0. So we know that activity I is proportional to the number of atoms that have not yet disintegrated. That means I is directly proportional to n. That means number of atom. That means as the number of atom as much as the number of atom present in that radioactive substance, at that rate or in that proportion, activity will be activity of the radioactive substance will be there. That means activity depends upon the number of atom present in the radioactive substance. So we can write I is proportional to n. So we can write this equation. In terms of number of atoms. So we can write n is equal to n naught e to the power minus lambda t. Okay, so lambda we can calculate lambda. That means if you simplify n by n naught is equal to e to the power minus lambda t. That means, or we can write n e to the power lambda t. Okay, that means we can write log or ln n naught n is equal to lambda t. Okay, so t will come here. So lambda is equal to 1 by t ln n naught by n. Okay, or in terms of, if we write in terms of log, then it will be 2.303 t log n naught by n. So here n naught and n naught is the number of atom of radioactive substance when time is 0, and n is the number of atom when time is t. Okay, now if we calculate half-life of this radioactive decay, then what will be the t half? That means half-life, that means t half. So this n will be n naught by 2. Okay, so we can write from this equation we can write n naught by 2 is equal to n naught e to the power minus lambda t. Okay, so t, okay, so here t is equal to log it will be ln 2 by lambda, so it will be 0.6930 divided by lambda. So in this problem you can see that the half-life of a radioactive substance is 20 years. This one. Okay, so the half-life of the radioactive substance is 20 years. Calculate the decay constant. In how many years the 3/4 of the given amount of the substance will disappear? That means if the total substance is 100, then 3/4, that means 75%. 75% for decay of 75% of the whole substance, how much time it will take. So we are going to evaluate that. So first of all, we have to know that this is 20 years. So first of all, we will get this year in second. So for 1 year, it is 365 into 24 into 60 into 60 is equal to 3.15 into 10 to the power 7 second. Okay, so for 20 years, 20 years, it will be 20 into 3.15 into 10 to the power 7 second. Okay, so as it is a first order reaction. So the for first order reaction, T half is equal to what? T half is equal to 0.6930 divided by decay constant or radioactive disintegration constant. Okay, so we will first of all calculate the decay constant. So we will calculate decay constant. Okay, so it is 0.6930 divided by 20 into 3.15 into 10 to the power 7. So it will be equal to 1.1 into 10 to the power minus 9. Okay, and unit of the decay constant will be second inverse. Okay, now for the second part of this question, that how many years 3/4 of the given amount of substance will disappear. So first of all, we have to know that this is a first order reaction or first order decay. So in first order, as it is given that the half-life, for half-life it is 20 years. That means if the total substance is 100%, this much, this is 100%, then half of the total amount needs 20 years to get disappeared. So this is 50%. Okay, so now next we have to consider this part, this amount we have to consider that this is the whole part. Okay, this part is this 50% got disappeared and this 50% remains here. So now we have to consider this 50% is the 100%. So from this total amount, from this that means 50% of this total amount, that means this is for 50%, half of 50% is 25%. Okay, so for this half-life is 25% and half-life for this 50% it will be also 20 years. Okay, so that means 50% plus 25%, that means what? 75%. Okay, and it needs what? For 50% it will need 20 years, and for this, if we consider this total, this is the total amount, then half of this total amount is this amount. Okay, so to disappear this amount, it also require 20 years. Okay, this because this is half-life of this total amount. Okay, so we can conclude that this 20 years and this 20 years, that means 20 plus 20, 40 years. 40 years, that means to get disappear 75%, this decay, this radioactive decay needs 40 years to get disappear 75%. Okay, now in this problem, a radioactive element gives 2000 counts per minute at a given time. After 1 hour, counts were found to be 750 per minute. What is the half-life of the element? So this is the problem. So for this problem, we have to know the general equation for the decay, radioactive decay, and this is the first order reaction or first order decay. So it is lambda is equal to 2.303 divided by t log n naught by n. Okay, so here you can see that this 2000 counts at a given time, 2000 counts per minute, that means they are giving this 2000 means n naught, the initial counts. Okay, they are giving that initial count is 2000, and they are saying that after 1 hour, that means t is 60 minute, and after 1 hour counts were found to be 750, that means they are saying that n is equal to 750. Okay, so we are putting this value here, 2.303 divided by 60 log 2000 divided by 750. Okay, so it will give you 0.010596. So lambda will be equal to this much. Okay, but they are asking that what is the half-life of the element. So as we know that half-life it is what is equal to 0.6930 divided by lambda. So 0.6930 divided by this value 0.01596 is equal to 43. It will be, you will get in points also, but you can neglect that. So it is 43 minute. So as we have put t in minute, so t half will be in minute. Okay, so this is the half-life for this. Discuss about first order reaction with a autocatalyst. So in this reaction, the product X is an autocatalyst. That means when there will be a reactant A from which there will be a product. Okay, so at the initial state, initial concentration, that means at the initial time, I am not saying that this is t is equal to 0, this is just I am saying that this is initial state. So at this initial state there will be a reactant and there will be a product. Some amount of product will be there and some amount of reactant will be there. So after after time t, after time t, so some amount of reactant will converted to product. So that product amount is x, suppose x, then only a minus x amount remains as a reactant, and this x amount is converted to product, so it will be b plus x. Okay, so now at the earlier cases, in the earlier cases, then we have seen that the rate is proportional to reactant, concentration of reactant. But in this case you can see that the x is an autocatalyst, so it will also affect the rate. So you can see that the x is in the product side also and in the reactant side also. So we have to write rate is directly proportional to reactant and product. So rate is directly proportional to reactant and also product. Okay, so we can write this K A P, or we can write K is equal to, instead of A we will put A minus x, and instead of P we will put B plus x. So that means we are saying that that means dx by dt is equal to K A minus x B plus x. So we will bring this part to here, dx by A minus x B plus x, and here it will remain K dt. So when we integrate this equation, dx by A minus x B plus x is equal to K dt, we will find out K is equal to 2.303 divided by T A plus B log B plus x A minus x. Here it will be A and it will be B. Thank you so much for watching this video. I hope this video helped you to understand chemical kinetics. If you like this video, please subscribe my channel and share with your friends.